asymptotes and limits as x goes to infinity are the same. It's the same thing. I guess they're kind of phrased differently. I'll go through that, but they're the same idea. How many of you guys check Schoology every day? I would encourage you to do that. So I put like the schedule on there every day. I put the worksheets on there every day. I put the lectures on there every day. Today I even put like the notes. I took a little bit of notes on what we're doing. I was thinking it'd be better. And I kind of reminded you, hey, the con is due on Sunday. I think it'd be beneficial to check every day. Okay, so to find these, the first thing you're going to do is simplify. You only need to simplify the highest power on the top and the bottom. And then you're going to compare. Where's the higher power? The higher power on the top, the higher power on the bottom, the higher power on the top. Just there. So, if the higher power is on the bottom, the limit is, and I'm going to fill it in a second, meaning there is a horizontal asymptote at. I will fill that in a second, but I wanted to like show you why. So I'm just telling you like, hey, here's what it is. So let's say I had like the limit as x approaches infinity, and I'm going to make it a simple one. Let's just say 1 over x. Yep. For 6th hour, you mean? Sure. I don't know what I'm doing, but I assume they'll tell me. Okay. Alright, thanks. But what do we do? I'm subbing in senior week, 6th hour. What would I be doing? Seminar for, so what did, like, I'll summon for Miss Keel. Alright, so accept that. Perfect. Okay. So let's say that as x was going to infinity, I want to know what the limit is of 1 over x. Well, if you just imagine, you know, if I just start slowly putting bigger and bigger numbers in there, what's 1 over 10? If I put 10 in for x, what's 1 over 10? 0.1. What's 1 over 100? 0.01. What's 1 over 1,000? 0.001. What's 1 over, what we have, 10,000? 0.0001. And as that number I'm putting on the bottom keeps getting bigger and bigger and bigger, what happens to the overall value? It gets smaller and smaller and smaller. This would be like I'm going halfway to the door, and then halfway to and I write down how close I am. And then I would go halfway again, and I write down my distance from you to the door. And I go halfway again, and I write down my distance from you to the door. I can take an infinite number of steps, but and the distance between me and the door will approach 0. It'll never actually get there, but it'll get closer and closer to 0. So when you got a bigger number on the bottom, imagine sticking in like 1 divided by 9 billion. It's not going to ever get to 0, but it'll be so close to 0 that that's where, you can tell that's where it's heading. And then, even if I gave you something like this, 3x to the third minus 4x squared plus the square root of x over 4x to the fourth plus 5x minus pi. I don't know, just make stuff up. When I'm plugging in such a giant number, the only thing that matters is the biggest power. So if I'm plugging in like 10 trillion and I cube it, subtracting this other part like doesn't even move the needle at that point. Like you're so big based on this power that doing this and this is like irrelevant. If I take 10 trillion and do to the fourth power, subtracting pi is like laughable at that point. It doesn't even matter. So when you get something like this, we're only looking at the highest power. So you can basically just ignore all the rest of that stuff. And then if I simplified the rest of it, couldn't I, if I wanted to, write 3x to the third over 4x to the fourth, that's 3/4 times 1 over x. So the 3 and the 4 I pulled out and made 3/4. I canceled out x to the third from the top and the bottom, so I just have an x to the bottom. Just like rewriting it. And then what is the limit as x of this, as x approaches infinity? 0. What's 0 times 3/4? 0. So kind of no matter what you do, if you have the bigger power on the bottom, you can simplify it basically all the way down to this. Or 1 over x squared, or 1 over x to the third, which will be the same thing, right? A giant number on the bottom and a 1 on top. So, if the higher power is on the bottom, the limit is 0. And there's a horizontal asymptote at, where's the horizontal asymptote? You can't just say 0. Horizontal asymptote is a line. What's the equation of that line? Y equals 0. That's like the only difference between limit and the horizontal asymptote. It's kind of the way you write it. So if I gave you this question, I said, what's the limit? You would tell me 0. If I gave you the question and said, where's the horizontal asymptote? You would tell me y equals 0. So same idea, same process, just like phrasing your answer differently. So this is your first bullet point there. Higher power at the bottom, we get 0. The higher power is tied. Let's do that. Higher powers. Are tied. The limit is meaning there is a horizontal asymptote at and again, I'll show you a couple examples, like how to explain why, and then we'll go back and fill those in. So again, the only thing that matters in this is the highest power. If I plug in like 10 billion and cube it, the number is so big that adding 2 is just like, it's just stupid at that point. So you can basically ignore everything, not basically, you can ignore everything that's not the highest power. Well then if I simplified this, what would happen to the x cubes? They'd cancel. So when the highest powers are tied, they essentially cancel. And what I'm left with is this. But there's no x to plug into, so I don't care what x is. Your answer is going to be 3/7. If I let x be 10 million, you're going to have 3/7. If x is 2, you're going to have 3/7. If x is 100 trillion Google zillion, I don't know. It's 3/7. So Well, the highest powers are tied. It's just the coefficient of them that becomes the limit. So the limit is, I'll just say coefficients, meaning there's a horizontal asymptote at y equals the coefficients. That sounds more confusing than it is. So if I give you this one, what's the limit? 4/3. This stuff doesn't matter. And then you can think about it two ways. Okay, well, they're tied, so I'm just going to look at the coefficients, and that's 4/3. Or you could just cross out the x squared and be like, well, the only thing I have left is 4/3. Does that make sense the way I wrote it up here? I'm not sure that's like the best wording, but I think you know what I'm saying. Okay. So the only situation left then is if the higher power is on the top. There's a few examples there. I made a nice little worksheet. Yeah. That's supposed to be negative infinity. But hard to see. This is supposed to be as x approaches negative infinity. Better? Sorry. And this one's negative 2, but I think that's a little more clear. Yeah.
So are these not all examples of oh wait.
That last one is how you're looking. The E one? Or no?
No, I
which, like in most equations you get, the higher power's on the top, because most equations aren't even fractions. So usually there's not horizontal asymptotes. So if you just think about this, like this is just y equals x. If I graph y equals x, you just get this diagonal line. Are there any horizontal asymptotes in that graph? No, it doesn't level off as you go all the way to the left or the right. It just kind of goes up all the way that way, and it goes down all the way that way. And there's no like smooth leveling off part. So in this case, the higher power is on the top, because the bottom is really just like 1, even though I don't really write it. So then you got to just think about, is it going to be positive or negative? So you're kind of plugging in infinity. Just think of some giant number. So if I stuck a giant number in for x, if I put an infinity in for x, what am I going to get? I'm going to get infinity. It's going to be positive. So my answer here is positive infinity. And that's shown by the graph, too. Like, as x goes all the way to the right, as I keep going to the right, isn't the y value just getting more and more positive and bigger and bigger? Yeah.
So, because it's like x over 1 is equal to 1, but if both to like first power, so
They're not, though. So on the bottom, if we wanted to get super technical, this is x to the 0, because what's anything with a 0 power? So your bigger power is on top. So like it really could be written like that, x to the first over x to the 0, and then. Alright, second one is x, so for x cubed, and again, if you think about the graph goes like that, there's no horizontal asymptotes, there's no spot where it like levels off. This way it goes up forever that way, and this way it goes down forever that way. So I know my answer is going to be positive or negative infinity because the higher power is on top, because there isn't even a bottom there. And then my job is just to figure out if it's positive or negative. So if you plug a negative infinity in and you cube it, what do you end up? Do you end up with a positive or a negative number? Negative. So it's negative infinity. And that's the other side. So that's as x goes to the left forever, that means we're going down forever. So that's all we're saying here is that this goes down to the left forever. This one here, so the higher power is on the top, right? So the -1 doesn't matter. You can cross off, like this could be plus something here, it doesn't matter. All I'm looking at is the highest power. Highest power is on top, so my answer is going to be positive or negative infinity. I just have to figure out which one. So if you plug a negative number into the top, you end up with a positive or negative. Positive. If you plug a negative number into the bottom, you end up with a negative. Positive divided by a negative is negative. So then your answer has to be the negative infinity instead of the positive. And this last one trips people up, but if you think about plugging in infinity, where's the higher power? On the top or the bottom? So basically I'm asking you what's bigger, infinity or 2? Now, the higher power is going to be on top here, because that's a lot bigger than 2. And these would both be positive numbers, right? Squaring something makes it positive. So this would be positive. Or that. Questions there? Alright. We're going to do a quick little thing here. And then so I'm just doing like simple problems still, simpler, and then we'll get into a little more in depth in a second. Try those. There's a couple more, but I'll like scroll down after you've done the first couple. If I show off on it once, is that still big enough? Back row people, can you still see? Everybody not see? Anybody want to forget to say any words? Thank you. Thanks, Jasper. You know what HA means? Or was that last note? Good time. This class needs Gessner in it. Class needs Gessner in it. Somebody would actually like speak. Say, ask questions. I mean, I understand he acts like an idiot sometimes, but it's like at least something. Someone vocal. Or your brother. No. Have you guys been in the same class a lot?
This is the first year.
That you haven't been?
This is the first year that we have.
Oh, you have been, really? What class?
English, gym, and maybe business. If you're done, put your pencil down so I can get an idea of who if I should be waiting or not. Oh, sorry, I forgot to turn this is better. You can always, if I forget, you can go do it or yell at me to do it or whatever. It's not a lot easier to see or not? No big deal. It is a lot easier. Is Richard back there? Behind Jack? No, Richard. Okay. So for this first one, so every time you see a limit as x goes to infinity, the first thing you're thinking is higher power, horizontal asymptote. So then I'm looking, okay, the higher power here is on the bottom. That's all I have to look at. The higher power is on the bottom, the limit is 0, and the horizontal asymptote is at y equals 0. If you just put 0 here, it's going to be marked wrong. An asymptote's a line, so if you just say 0, you're not really describing a line, so make sure you're putting the y equals 0 part of it. Limit as x goes to infinity, so they're telling me, or I told you the limit was 3/5. You know the powers are the same, so you look at the coefficients. So one number had to be here, had to be a 5, and then your horizontal asymptote would be at y equals 3/5. As x goes to negative infinity, well, the higher power's on the bottom, so I don't really care if it's positive or negative, because it's just going to be 0 anyways. So 0, y equals 0. This one, I guess, technically could have two answers. So if the limit was 0, that means the highest power is on the bottom, right? So this, you could put, I was thinking of 1, but I guess you could put a 0 there, or a 3/2 there, or a 2/3. I guess there's a million answers. As long as the number you put there is positive and less than 2, it's correct. and then the horizontal asymptote would be a y equals 2. Negative infinity and higher powers on top, so my answer is either going to be positive or negative infinity, but I got to kind of think through the positive and negative signs. So again, ignore all the other stuff. If I plug a negative number into the top, would it come out positive or negative? Negative. A negative number into the bottom, come out positive, so then a negative divided by a positive is a negative. So your answer is negative infinity, and where's our horizontal asymptote? There's not one, so like does not exist, or NA, or something. Questions on that little set of problems right there? Okay, so the next thing then is they usually make you simplify stuff before you compare. So let's say something like that. Remember, all you have to simplify is the highest power. Like, I don't know how to take the square root of 16x to the 8th minus 4. But I do know how to take the square root of 16x to the 8th. So these just basically just cross them. What is the square root of 16x to the 8th? 4x to the what? So what power is a square root? Square root's a 1/2 power, right? So this is basically like 16x to the 8th to the 1/2. So 16 to the 1/2, or the square root of 16 is 4. When it's power to a power like this, what do you do with them? You multiply together. So the square root of x to the 8th is actually x to the 4th. I feel like some people were trying to square root 8 there. That's a really tempting thing to do, but you're not. You're just dividing it by 2 or multiplying by a half, whichever way you want to look at it. And then the bottom is 3x to the 4th, so the highest powers are tied. And your answer is 4th. It's just that like step of simplifying first that can trip you up a little bit. Do that. If you square root it wrong, you're gonna get the wrong thing will happen. Think about it backwards too when you're like square rooting the power. It might help you. Like if I took this 4x to the 4th and multiplied it by 4x to the 4th, wouldn't you add up those two powers and get 8? So it helps you kind of make justify that it is the actual square root. So the square root of 9x to the 16th is it 3x to the 8th or 3x to the 4th? 3x to the 8th. And again, if you did 3x to the 8th times itself, you get a power of 16. So that should kind of help you verify that you're on the right track. So you square root the number, but the power you divide by 2. The bottom you have x to the 5th, so your highest power is on the top. We're plugging in a positive number, so everything's just going to be positive. How many had infinity there? Let's say... So that, which looks like it's much more of a pain than it actually ends up being.
So remember, the only thing you care about is the highest power. None of the rest of it matters. So I don't have to FOIL. I just have to. All you care about is the first part. So I'm just going to do that. That's 6x squared. I don't care about the O or the I or the L because they're all going to be like lower powers. So it doesn't matter. So there's, like, you can save yourself from work because there's some work because I don't care about the rest of it. So the bottom, I'm just going to go, oh yeah, that's 20x squared, and I don't care about the oil. Highest powers are tied. So you would get 6 over 20. Or if you want to, you can get 3 over 10. Questions? Is it right? Alright. So I got a worksheet. There's a couple worksheets with a couple sets of answers. Got time to work? See you tomorrow. Keep going. I want you to know how to do it for when there's a time. I want you to ask me questions if you have them, but I don't know. Fair enough. And the answers are on there too, so you can check them yourself.